A very warm welcome to the very first webinar from the Main Tech event in collaboration with long-time exhibitors Reliability Maintenance Solutions. Thank you all so much for joining us. The Main Tech event is over 40 years old and has really stood the test of time. Working at the heart of the maintenance industry, we recognise the importance of regular engagement with our visitor audience, and we are proud to be part of the marketing process for our exhibitors in providing channels such as these ones to showcase their products and services. The subject matter today is a particularly exciting technology for the maintenance industry, and we are delighted that the inventor of Motion Amplification, Jeff Hay from RDO Technologies, is joining us to explain how it works. In addition, we will hear from two engineering professionals, Phil Renshaw and Paul Phelan, who have implemented the technology at their plants. There will be a Q&A session at the end of the webinar, so please feel free to post your questions live, and the team will endeavour to answer as many as they can within the time frame. If we can't get round to all of these questions, the team will respond to you after the webinar. Without further ado, all it takes now is for me to hand over to our hosts, Reliability Maintenance Solutions, and our chair for today, who is Keith Gallant. Thank you.
Thanks, Joss. Appreciate that. And thank you, everyone, for joining us today. I know we've got people from all around the world, so it's good morning, good afternoon, and good evening. So everyone's welcome. We really appreciate we've already had your input, your questions that you've put forward, and like Joss said, we are going to try and answer those throughout today's discussion, and any that you decide to put in the chat, and some of those that you put in, we are going to discuss at the end in that Q&As as well. The real purpose of today, why we wanted to do this webinar, is really because we hear a lot about Industry 4 technologies, and there's some revolutionary technologies, some step changes, and a lot of questions about how actually you can take these new technologies and use them in your plant in a practical, meaningful way and generate value for yourselves. So with motion amplification, it's one of those kind of giant leaps. It's a leapfrog of technology, and it's so advanced. It's how can I actually get this to be of value in my plant is the question, and we're going to try and answer that today. Of course, we're going to hear from Jeff, the inventor, and he's going to go through the technical aspects of it and do a little live demo as well, so you can see actually what it looks like to use the technology. You'll see how long it takes to collect data and a bit of functionality there. And then we're going to hear from Stuart, my colleague from RMS, Stuart Walker. He's a practitioner like myself. He's out every day using the technology, and he's going to go through some real-world case studies that we've both shared over the last 3 or 4 years, and see how you can actually use it practically on plant in different ways and get that value from it as a measurement tool. And then we're going to hear from, like we said, the two engineers. We've got Paul Phelan and Phil Renshaw, both from very different backgrounds, from different kind of plants, and the way they've used the technology is very different as well. So their experience is going to be quite interesting, just to hear what they've got to say about how they use the technology. We call them power users, so it'll be nice to have a chat with them and catch up. So I'm going to hand over to Jeff now, if you want to take it away, Jeff.
Yeah, sure. Thanks, Keith. So I'm going to share my screen here and start the presentation. So I'm going to talk a little bit about, just a little bit of an introduction before I hand it over to Stuart to do the case studies. So I just want to give a little bit of background about motion amplification technology and how it works and in how it's used. One of the things that I think that is changing, the technology around us and the way that we perceive things. is through the use of camera technology. And so, cameras really are everywhere. They are, kind of present in everyday life, and they've really changed the way that we do things. Cameras invented, in the turn of the century, but really the digital camera is really what has revolutionized the things around us. So here's the first digital camera. You can see it on the screen from Kodak, and then we've also got an image here in the bottom of the CMOS sensor, which really started to change things. That enabled the camera to go into the cell phone, and then now we have cameras in cars. So you can see an image of a Tesla there with the camera, and cameras now actually help us drive cars, and really that application base is really growing. Cameras allow us to, discover new galaxies. This is the image of the Hubble Deep Field, and in an area of space that we thought was essentially empty and void. You place a camera in that area and collect light for days, and the next thing you know, we've got more galaxies there than we ever thought existed, and we see that through cameras. We're using them again to drive cars. They're used in AI to distinguish objects, to tell the difference between a human and an animal. They even show me who's at my door. So a Ring doorbell, for example, that my cell phone alerts me to let me know that there's someone at the door, and control traffic. So they know when you run a red light, and then they send you bills. Cameras now automate billing processes. Every time I drive across the local bridge, I get a toll in the mail automatically from seeing me drive across the bridge. And so as this application base grows, we want to be able to use that for vibration and machinery monitoring. And so that's sort of where motion amplification comes in. So I'm going to play this video. You'll see a series of videos in this presentation. Just know that the videos should be played back smoothly on your end. Maybe perhaps the internet connection is different for everybody, so there might be a little bit of a jitter, but they should be playing back smoothly for you. But what we're seeing here is motion amplification video, and I'm going to start this over so you can kind of see at the beginning here. With your eye, you don't really see any movement, but the motion amplification essentially turns every single pixel in the camera into a sensor. And now you've got millions of displacement sensors. Even a modest camera has 1 million megapixels in it. And that's even, a small resolution camera. And so you can see also we can start to do some interesting things like plot charts and graphs and pull data out. And I'll do a short demo showing that. But here you can't see any motion. And now you can, turn on the amplification process, and you can actually see the motion in it. And so this allows the camera actually to be a machinery monitoring and vibration tool that we can actually visualize motion, and then also do a lot more. Track the motion, measure the orbits, show the plots, the paths, measure these things, do spectral analysis, and we'll show some of that in the case studies. So a little bit about the technology. I mean, you see this plot over here on the right. That's a spectrum. That spectrum tells you something about the object, right? Maybe it's the combination of the two plots. Maybe it's the relative amplitudes. Maybe it's the amount, the level each one of those peaks hits. But there takes some an analysis to really understand what's going on there, where this video really shows, when one side's going up, the other side's going down. And so it makes it a great communication piece as well as an analysis piece. And so, really what we're trying to do is leverage the fact that we've got millions of pixels, millions of sensors there, that we can all use them in tandem and sort of use the human brain to just look at it and quickly make an assessment, right there on the spot. And then also communicate that issue to other people, even if they're a non-technical person. So here we can kind of see as you scale up with your data collection process, it gets pretty cumbersome and pretty expensive to do that. But with motion amplification, you can think about adding 1 pixel or 2 pixels or a million pixels. It really makes no difference because it's all nicely packaged in a camera. And you can use that as your sensor and your data collection. You can sort of do full field vibration. So a little bit about the technical details of it. It's really measuring displacement. It's that's fundamentally what we're measuring here, and that makes it a really nice tool because there's not a lot of displacement tools that are common throughout data collection with machinery and vibration. You can do it live. I'll do a demonstration here. You can amplify it, plenty to, up to hundreds of times. And you can show individual or overall motions, both. And that's really key because some faults manifest at individual frequencies. 0.01 mils, you can essentially see, essentially anything that is of interest to you. So let me go into a demo here. And I'll show you some of these benefits. We'll talk about, why it's, a complementary tool and how it's improved safety. And then also it measures this large field of view. That's this full field vibration technique, being able to see the entire field of view and pick out different parts is really important. But I want to also really emphasize this communication piece. And I mentioned it before, but it's really, I like to usually think of it as one part analysis and then, equal part communication, because, if you collect data and you have the best data in the world and, it really tells the story, this spectrum tells the story of what's wrong with the machine. If you can't get buy-in from that piece of data to get, movement on repairing a machinery, it's really as if that data didn't exist at all because you've really not been able to take action. And so that's a really important piece, that last bullet there, the actionable information, because you can actually do something with it. So here's, you've got a couple ways to deliver it. You've got the normal troubleshooting kit, which is sort of the thing you take out and do the analysis on the spot, spend an hour at the machine, 30 minutes at the machine. You can use a high-speed camera, which is the Iris MX there. But also down here at the bottom, we have the Iris CM, which stands for continuous monitoring. So this is a fully networkable, scalable solution. You can put these systems together, connect them over a network. They all talk to each other. And you can do online continuous monitoring, send videos to the cloud and get them on your phone, and essentially deploy as many cameras as you want through a facility, and they're all interacting with each other. Okay, so let me get straight to the demonstration here. So I'm going to turn on a camera here. I've got a rotor kit that's a little machine vibration trainer that I've got set up. I want to turn it on. So, I've already focused this. You would normally focus this, set your exposure, that sort of thing, the brightness. We've already done that for the sake of time, but, it takes, 5-10 minutes to set up. One of the things I want to show you is this live amplification. If I just hit this button, I can immediately show live amplification. All the videos that you see here, this is the process it takes to get them. There's no magic going on behind the scenes. It really is this quick to get them. So you can actually show and do scanning right there in the field with this live amplification. If I wanted to know how much that's moving, live on the spot, I can draw a measurement here and actually get a time waveform and a frequency spectrum right there on the spot. That tells me that's moving, 1 mil in one direction and 5 mils, or 10 mils peak to peak in another direction. Let me take a data collection here. So I'm going to take a data collection here just for about 3 seconds. And then I'm going to go into the amplification process. I'll turn that rotor kit off so it's not so loud. And then here we've got the amplification software. And you can see I can play it back and it's instant. There's no processing time for this. And again, if I wanted to make a measurement, you just sort of draw a box here. You can make as many of those as you want. Pretty easy. I'm going to move that box up here to the sort of the tip of that cantilever beam and make a measurement there. And I mentioned that you can filter as well. You'll notice that I've got a couple frequencies here. If I went up here to the filter screen and I wanted to isolate one of those, I want to show the Y, and I can show those together. I'm going to add a filter. It's really simple. It's UI, just to be able to show what frequencies are present, because certain faults manifest at certain frequencies. So if I were to isolate that one, green means it's going to stay, and I hit apply, it's going to go through the process of filtering the data here to only show that one frequency. And that's really important because, again, certain faults manifest at one frequency. So another thing I wanted to demonstrate too is just kind of the speed at which you can do this. The key part here is the fact that this is field usable. All this can be done in the field. You know, you make an analysis and you look at it right there on the spot, and you can actually see what's going on with the asset. So now if you remember, that motor was moving quite a bit, but if I were to now play this back, you can see that the only thing moving there is the beam, right? So you can see that beam moving there up and down, and the motor's totally frozen, right? So again, we filtered for the beam frequency. If this was a fault, it would manifest and show you exactly what the fault is. And again, let me just go back for the sake of demonstration here and show the original where everything was moving. You can see now we've isolated that motor frequency. So again, I just wanted to show a short little demo to set Stuart up here. I'm going to hand it over to Stuart. I just wanted to show, in preparation for what the case studies he's going to show, it really is going to be able to show exactly how easy it is and quick to collect these videos that he is going to show.
Thanks for that, Jeff. Great presentation. Yeah, it's Stuart Walker from RMS, and I just want to go through now a few case studies and examples of the technology. And as Jeff's already mentioned, for me, one of the most powerful things with this technology is its visual aspect. And I've been to a lot of sites, and quite quickly we learned that the actual visual side of it was key, because people could understand the faults you're seeing. So, Jeff, if you want to play the first slide, please. Yeah, so we've got a pump here, and as you can see, there's the standard footage. And then as it moves, you can see the base, the concrete base has failed. And this becomes really clear with the camera. There's your standard footage, and you can see there's cracks there. So very easily you can see this whole base needs repairing. It's not just a fault on the motor or pump. This next set, they had lots of reliability problems with these pumps, and we can see the motion there really bad. Again, base problems. And I think also you can see some misalignment. The pump and motor are moving out of phase. So this needs, again, a total overhaul. And again, beauty with the camera, you can look at the whole system. We can see the pipe trying to rip the pump off the bed, and we can do a measurement there as well. So from a communication tool, unbelievable. And I've been to sites where faults that weren't repaired before are suddenly being repaired because people understand the problem. Next slide, please, Jeff. Sorry, Jeff, next slide. Yeah, so here we've got, again, it's a base problem. These were newly installed pumps and a lot of vibration on them, 20 millimeters per second, bearing faults, seal failures. And the CBM team wanted us to have a look with the camera, and the camera just exposes all the weakness with the base, every little looseness. So eventually these bases got replaced. And now you can see we've gone from 20 millimeters per second to 1.2, a 94% reduction. But what's key in these videos, you'll notice when the vibration levels are low, when we amplify the video, you don't actually see any motion. So in other words, you can't make a good machine look bad. Next slide, please, Jeff. Okay, so this machine, this is a higher frequency machine. This is a fan doing 6,000 RPM, and they were getting raised vibration levels on the motor at the rear. So when we looked with the camera, we could visualize the whole asset, and we could see vertically the motor was had the motion. And when we looked closer at this, we found quite clearly, again, it was the way the base had been mounted to the concrete plinth. There was packings used, which wasn't good. And you can actually see the motion there. It's not excessive, but it's enough. It's doing about 10 millimeters per second, this one. We could even see a loose bolt there. And you can see the flexing of this structure. But what you've got to imagine is this thing is doing 6,000 RPM. So this is occurring really often when we're looking at the data. We do lots of different angles when we get on site, sort of document the machine. We don't just take one shot, we'll do different angles, look at where we see the motion. And you can see on this right-hand side, this next shot really shows the problem here with the packings. You can see the motion there, it's resting, it's flexing, and this is the problem of this machine. So they're currently on with repairing this, and I'll get some aftershots. Next slide, please. So this was an interesting pump problem we had. Again, it had repeat failures, this bearing, seal and bearing failures. And it turned out the problem, if we watch the video here, this is a standard footage, and then we see the motion amplified. Can you see it's sort of like flexing the bearing? Initially, we thought it was loose, but when you look, everything's tight. So these are actual forces inside. So there was definitely something not right. After we saw that, we said, what's the history of this machine? And it turned out the housing had been machined incorrectly 2 years previous with a failure, and that was causing the problem. Next slide, please. So this is one I actually got last week, the follow-up. Very often pumps are put on VSD drives, variable speed, in the modern way of doing it. But unfortunately, if you hit a resonance, you're going to have problems. So if we play this video, I'll show you here the before and after. So this is the before. It's resonant condition. The bass is flexing, lots of vibration up to nearly 20 millimeters per second. Stiffen the bass, and you can see there's a massive reduction from, I think it was 18 down to 0.5. Big difference before and after, and it's so visual with the technology. Next slide, please. So we're going to look at some piping examples now. The camera really excels at this because we can do non-contact, and a lot of piping, especially in the oil and gas industry, is quite remote. You can't put accelerometers on there easily. And we found the MA is a great tool for scanning. So if we play the first video, like Jeff showed earlier, you can use the technology in live mode. So when I looked at this distillation plant, I'm quite far back here. I'm looking at the whole asset live in the field, and I could see in the center section there's some pipe work that's vibrating excessively. We do a quick non-contact measurement. We can see it's been excited by the flow, and its natural frequency has been excited. So what we did, we got closer to the asset, we got up there, got some closer shots, we could really see what was happening. And this is putting a lot of strain on the connections here, on the flanges to the column. So what we do, we can do a non-contact measurement and actually apply some energy guidelines sort of for pipework vibration that can tell us if it's an actual problem we need to look at. And we could see, we look at the frequency and we look at the amplitude, and we could see this was definitely in the concern bracket. So we would recommend here some more pipe support. Okay, next slide, please. Yeah, if you want to play that one, please, Jeff. So this is a steam turbine, brand new, and they had lots of lube oil pipework vibration. They could tell it wasn't great. This is a brand new machine, and we was asked to look with the camera at what can we see. So this is what you see with your eye, and then the camera, lots of motion going on. And if you remember when I said we're seeing it with the camera, it's generally usually out of spec. So we're taking lots of different angles. There's the oil cooler, HPN, the LPN. They was all showing quite high vibration levels on this pipework. And it was at a frequency of the generator, okay, up to 50 millimeters per second on some of this pipework. So we applied the standards, and we can see a lot of it was out of spec. So what we then did, the turbine was off, and we did some bump tests just to confirm the natural frequency of the pipework, which was very close to the generator at 25 hertz. So then the next thing we did, and this was really key, we was on site and we wanted to do some temporary bracing. So I went into live mode with the camera. Keith's here and he's actually tightening up a brace. So I'm watching with the camera what's happening to all the pipework, and he absolutely killed it at that point. And for me, it was like having another pair of eyes on site. So we added some braces in key locations, and this was the before shot. And then we'll show the after, and we reduced the levels massively. I think we've got them down to like 1 millimeter per second, 2 maximum maybe. This is before, and this is after. But I can't stress enough how it was like having a second pair of eyes. It's just unreal when you've got this technology and you're trying to do a job like this. You're really worried at times, if I brace it here, what's going to happen elsewhere? Well, with this camera, we can see everywhere, so it's not a problem. So again, after we'd done these scans, we did some measurements just to compare to before, and you can see on the graph we're down at 0.7 now of a millimeter per second. The problem with this pipework, if you leave it with high vibrations, there's a real chance you can fatigue fail pipework, and as we know in the oil and gas petrochemical industry, that can serious consequences for pipe failures. So the technology worked really well in this example. Next slide, please. Okay, if we play that one. This was an interesting one. A lot of sites have used the camera for scanning large areas of plant, and this was on a survey of doing lots of machine trains, looking for problems, and you can actually see on this one where the weld's going to go. You can actually see it's that visual. So again, it's been excited. It's well out of spec. And on this one, we recommended a brace in the direction of the motion. And we can see here the before and after 94%. So there's no issue now. This is small bore branch is going to fail. So yeah, a nice job, that one. Next slide, please. Yeah, play this one. So this is an interesting one. This one's a lot higher frequency. So this was a glycol pump. It's before and after this. On the left's the before. This is the after shot. And it was actually the pulsation frequency of the pump here. So on the left, you can see quite a lot of motion on the pipework. They were getting problems with a pump failing as well. And this is at 250 hertz, this vibration. So we use the MX camera, we could visualize the pulsation frequencies, no problem. But we can see a dramatic drop in vibration with the extra clamps we fixed on. But what was really interesting with this machine, the main problem was actually the pump failing. It was only lasting 3 months. And when we looked at the motion amplification videos, you'll see a shot coming up. It was quite clear it was the pipework that was flexing the actual pump body, and these are tight tolerance. So the left shot's before, the right's after. So we dramatically reduced the flexing on that pump, which in turn just, I don't think they've had a failure since we've done these mods now, which proves that it was the pipework causing the pump problems. Okay, next slide, please. So what I'm going to talk about now is just some structure ones. We've had a few questions actually saying how far away can we be? Well, if you've got a structure and there's motion there, we can visualize it. So Jeff, if you'd like to play the next slide, please. So the first one's quite a large chemical plant, lots of different sections of plant, and there's the standard footage, and then there's the amplified. And you can see on the left-hand side, there's quite a large piece of the plant that's vibrating. This is very low frequency. The camera can handle right down to 0. And you can see we can get a measurement off there. A lot of structures vibrate quite low. This was at 1.46 hertz. So on the videos, we actually speed it up to see the motion. And the result of this, it was being excited by an agitator nearby. When we turned the agitator off, the whole structure stopped. So we knew it was that. But the fix was putting some bracing around the bottom of the structure itself, which cured it quite well. I need a follow-up on that, but it worked well. Next slide, please. Right, just to show you the scale of this camera, these columns are on a petrochemical plant and they're around 200 meters away. And you can see the right-hand column, it's quite scary actually, quite a lot of motion. The guys on site knew it moved, but we were quite shocked when you can actually see it. And we can measure that. As long as we know the distance to the point, we can actually get accurate measurements. What was the cause of this is it didn't have a dampening device. A lot of these towers have water tanks there that sort of stabilize the column. This one didn't, the others had. So I think they're looking at maybe implementing that on this site. Okay. Next slide, please. So we've also used the camera a lot offshore, and we can see here a crane that had a severe vibration problem. This has now just recently been fixed with a dampening device down the center. So even though you might get motion of the boat, the camera can deal with that. We can filter to the frequency of interest or use stabilization in the software. So yeah, that's worked really great. So I hope you enjoyed those case studies. I'm now going to hand over to Keith. I'm going to share my screen, and Keith's going to talk to Phil and Paul, who are some great guys who use the application in the field and are actual users out there. So.
Yeah, thanks, Stu, and thanks, Jeff. That was really good. Really informative, and I think we've answered some of the questions there just by going through those slides. It was really good. Thank you very much. Funny looking at those pumps as well. I don't know if any of you guys have pumps that can dance like that on your sites, but they were quite impressive videos. So we're going to have a chat firstly with Phil. Phil Renshaw. His bio's on there, so I'm not going to labour that. We'll have a little chat with Phil. What can you tell us about your background a little bit first, Phil, your engineering background?
So thanks, and hello to everybody. I started off as an aircraft technician in the British Army a long time ago now, actually. So I've been around helicopters for, all of my military career. So obviously we were quite engaged with balance and rotor vibrations and things like that, because helicopters tend to vibrate. So that kind of led me naturally into what this motion amplification technology can show. And since I've left the military and worked in nuclear and now in the chemical industry, what I've moved towards is trying to improve maintenance and reliability in those plants that I've worked in. So when I got the opportunity to get RMS guys out to plant to show how this thing works, it was a real game changer for me, having spent many years with stroboscopes and flag tracking and things like that, and rotor tuner technologies to actually visualize that quickly was amazing. So a real game changer.
Let me ask you then, Phil, I know you've told me at your plant, we can see it there, is in terms of reliability, maintenance reliability, the focus that they've got in maintenance, and their approach to it at your plant has been transformational, hasn't it, over the last 18 months? So I was wondering if you could just give us a bit of a describe what it was like when you arrived at this new site to you. What was it? What was the attitudes like? What was the culture like? And how was the reliability on there?
Yeah. So I mean, there's a couple of phrases which have been banned over the last 18 months, which I'll talk about in a minute. But the culture was, and to an extent, is very much, if it isn't broke, don't fix it. We'll fix it when it fails. When it does fail, stick a bit of duct tape on it and run it again. And when it fails again, do the same thing again and just keep the plant running.
Yeah.
And the plant's been operated like that for a significant time, really. And therefore, people fall into bad habits and everything's rushed and there's no time taken over, quality of installation, commissioning work and things like that. So my focus really was about getting back to basics and about addressing that culture of reactive firefighting mentality. And really the whole thing about the plant has been about the cultural change, not necessarily the technology, although the technology has obviously helped massively.
I was going to say, there's a lot of different technologies that people would usually go for first, aren't there? Whereas Motion Amplification is quite advanced in terms of so new, isn't it? What made you think that, right, well, I'll sidestep those things straight away and go straight for MA? What was it that kind of go along those lines?
Well, one of the things I think that most engineers will agree with, and probably the struggle you have is investment and funding. So if I stand in front of the board and say, okay, so I need to spend X amount of $1,000 on this piece of technology or this piece of equipment because the frequency at 15 hertz is too high and it's 40 millimeters per second squared, I might as well be talking in a different language to them entirely, because I really am. But if I can put a video clip up there, the 1920s horror show, as we call it, I can show them immediately what the problem is, and literally as soon as I've put these videos up in front of requests for funds, it's been granted almost immediately. It's such a powerful way of demonstrating what's going on the plant.
Yeah.
Not just that, not just with trying to seek funding, but also with the guys as well.
Yeah,
so that the operators
help get engagement, involvement.
Yeah. So I've taken operators out onto the plant with the technology, and set up the camera with them and said, okay, so you're complaining about this pump always failing. So let's show you why it's always failing. Put the camera on, and literally within 10 minutes, they are blown away with what they can see. I didn't realize that wasn't bolted down. I didn't realize that was like that. I didn't realize that the base was flexing that much. All those kind of things, and it makes a real difference, and it makes them think about, even basic things like torque loading bolts and like making sure alignment's good, making sure the actual installation's been conducted properly. It's been quite surprising coming from an aviation background and going into a different industry. For example, when I arrived on site 18 months ago, we had one torque wrench. I could not get my head around that.
That's crazy, isn't it?
So being able to show, what's actually happening on the plant in real time is a massively powerful tool.
Yeah, I remember you actually saying as well, you had the little phrase about helicopter analogy. You said, do you remember that, about the bolts coming loose on it? Does that ring any bells?
Yeah, so I mean, in aviation, obviously, and for those people who have come from that background, vibration when you're flying is not. Some of it is okay. It's going to happen. It's going to vibrate. Helicopters vibrate. It's what they do. But if you let something vibrate to the point where things are starting to loosen themselves off, which does happen, sooner or later you're going to lose something critical. And when you do, unfortunately, in aviation, that tends to result in a fairly significant fatal accident. On plant, what it'll lead to is the significant and catastrophic failure of a system. Hopefully not injure anybody, but potentially could be. So not torque loading things, not bolting things down correctly, not following an installation guide, eventually is going to wear your plant out. And the good thing about the technology is being able to demonstrate that really, really quickly. So we use it for commissioning now. We use it for a lot of things where, if we're not sure about something, we can go out and just check it. And certainly where we've had contractors on site who've installed new equipment, we're straight out there with a camera. So that's installed, is it? Okay, let's put the camera on it and let's have a look, see what's happening. So and we can get things rectified immediately.
You've got that with your team now where they want to go and they want to get the camera and look at something and see what the result of the work is, isn't it?
Yeah, I mean, we've used it quite regularly on site. And actually, we've had consultants who come and help us out with projects and stuff like that, and they've seen the technology as well. So actually, I've been asked to go and look at other sites to give them a hand when they've had an issue. Through our customers and suppliers have said, "Oh, we've got a bit of a problem. Would you mind if you just came and had a look?" And obviously, Stu's seen some of that work that we've done, and I do share regularly with the guys from RMS and other sites to sort of say, "Look, we've spotted this," just to share it out and show people what's going on.
That's cool. It's brought us on nicely, actually, because you've got one to show us today, haven't you? These R10 pumps. Do you want to talk us through what goes on here?
Yeah, so basically we had a problem with these circulation pumps on 2 of our reactors, R10 and 11. So this is before we did any work. So what you can see is a lot of pipework movement. The base is actually flexing underneath the motor and moving. It was basically just thrown onto some steel and then that's it. And you can see the frame moving and everything else as well. There's issues with alignment. The whole things were going all over the place, and we were changing couplings every 4 weeks on R10. So it was costing us, an amount of money. So once we highlighted that, we then put in a request for some funds, which we got, and this is what it looks like now. So we've got new bases down, we've mounted the pumps properly, we've aligned everything, we've strengthened pipework supports, we aligned the pipework properly. The only thing that's moving now is some small bore pipework, which we're also fixing on the sample port. But the level of vibration and the level of failure that we've reduced is massively significant. Going from changing that coupling on that pump and motor unit every 4 weeks to, running it for 6-8 months without doing anything to it, pretty much, other than standard routine maintenance, is massively significant in terms of your engineering hours and your operator hours. 4 hours to change a coupling, and we're saving that every 4 weeks, and that's 4 hours we can use elsewhere. So cool. And then being able to demonstrate that back to the company and say, okay, so you gave me this money to do this work, and here's the results, and this is how much time we've saved. So that's really important.
That after shots that you've got there, that being able to look at it afterwards is a real killer, isn't it? To just show that actually, yes, we do these works, we do it properly, and these the evidence to show that it has improved it.
Yeah, and as Stu said, in his case studies there, if there's nothing to amplify, it can't amplify it. So if it's, if there is no movement, if the thing's installed correctly and there's no problems with it, you can't just make it move. There's got to be some movement there for it to be amplified. Yeah. So it's been a huge improvement on our site. And like I say, it's not just the engineering team. For me, reliability is a team sport. Everybody's involved in it. So we've had operators out, we've had the plant managers out, and we've shown them the issues, and then they've worked with us to help us get the work done. So it's a really great technology to sort of get things started as well.
Yeah, thanks. So we just got 1 minute there. Let me ask you for the last minute, what kind of tips would you give for the guys out there watching today? How could they start implementing it? What kind of top tips have you got to help them get using MA and getting it on site and getting it accepted in the minds of the people who work there, the maintenance crew, and also the management?
So I think I'll go back to the sort of maybe the approach that I took was quite good. What I actually did is, instead of going out and investing in the technology, which is for some people is quite expensive, is getting the specialists, get people in who've got this technology, even if it's a mate of a mate who's got it at a different site, such as me. Get them in to demonstrate it on one of your really bad actors that you think there's a vibration problem or there's another problem, and then show your staff, your engineers and your operators what's going on with the equipment. It'll make a massive difference immediately to be able to show what's going wrong. Yeah. And once people see it, it can't be unseen. It's really that powerful. So that's what I'd say. I think what you've got to do is address the real sort of reactive element and I've always done it this way. And these are the phrases that we've banned, which is we've always done it this way and can't.
Yeah.
Because I'll go back to my military days. Can't means won't means jail. So there's always a way of finding a better way of doing something, unless you've really nailed it. So that would really be my advice. Would be get somebody in, get some of your real bad actors visualized, demonstrate that around everybody, and then let them get to it, and they'll make decisions really quickly.
Beautiful. Thanks very much, Phil.
Thanks.
So you heard it there straight from Phil. Free services for MA. If you check with him on LinkedIn, he'll be more than. So that's a good idea. If you want to connect with him on LinkedIn, you can always interact with him directly. Thanks very much, Phil. Appreciate that.
Thanks, guys.
So Paul, hello, Paul. How you doing?
Hi, Keith. How are you? You hear me okay?
Brilliant. Got you perfect there. I've got a really nice picture of you there and a beautiful site that's brand newly built. Looks lovely. So do you want to give us a bit of a background on yourself and your engineering?
Sure. Yep. No problem. So I'm a mechanical engineer. I started out as a machinery designer for quite a few years. So to design machines from scratch, and then kind of gradually moved into condition monitoring with vibration analysis. Spent a bit of time in Australia before I came back to Ireland about 5 years ago and moved into the biologics, which is pharmaceutical, but it's where we're actually growing cells for immunotherapies for cancer patients. So my previous plant, I actually had Stuart come over to demonstrate the MA camera because it had just come out, I think, about a year beforehand, and it was actually an easy sell because he caught a pump where it was just as simple as a loose bolt, and so the video came up. I showed it to my manager, and he'd never seen it before. He'd never seen the before and the after, and he just stood there kind of shaking his head. And his question to me was, "How quickly can you get this?" So, that was the beginning of it. And within a few weeks, we had the MA camera on site.
Yeah, I remember that very early on. You're an early adopter, weren't you? So, can you just give us we had a bit of background there on Phil's site, and it's very different at yours, and it's you've had 2 sites where you've used this technology, and you've actually had that brand new greenfield site, and you've been able to build a CM program from scratch, haven't you? And you've had a good budget to buy whatever you want. I mean, you've shown some great tools. You've got X-ray machines and all sorts of cool stuff. So, give us a bit of background. What's the culture like for maintenance there at those places?
Okay, so yeah, like you said, it's a greenfield site. There is a big budget there, but there's quite a big emphasis on having a return on investment. They definitely don't just buy something because it looks nice. So there's a strong emphasis on being lean, strong emphasis on being digital, and strong emphasis on condition monitoring technologies. So we basically have all the tools, most of the tools anyway, that you could want. And for the vibration program itself, I guess you could say we have a three pillar approach to it. So one pillar would be our IoT vibration sensors. One pillar would be a standard data collector, which is not used for a walk around program, but is more used for troubleshooting any kind of high frequency events that we have. And then we have the MA camera as well, which is for our low frequency events. So the analogy we sometimes give to it is that we are kind of like floating like a butterfly and stinging like a bee. So now it might sound a bit dramatic, but the way it kind of works is that our IoT sensors are always there in the background, and they're monitoring our critical equipment and any of the stuff that we would normally have on a walk around program. And then when it flags up that something is wrong, if there's a low frequency event and we decide now we'd like to put the MA camera on it. And well, that's when we take it out and we sting like a bee. So we take the MA camera out and we have like an intense focus on one asset just for that period of time until we have it fixed. And then when we have it fixed, then it basically goes back into the cabinet, and then we go back to floating like a butterfly. So it's yeah. I just thought that one up this morning. I thought it was a nice analogy for it, But what it means is that it frees people up, and it makes us lean. It means we don't have people doing preventative maintenance, and we don't have people doing walk-around programs. But when the time comes, we have the technology to intensely focus in on one piece of equipment. But we also have the people that are actually trained to use it as well.
So that just makes me think of earlier on, you've kind of mentioned it a little bit there as well, is if you've got a new plant that's been built and you're commissioning, so what you've just discussed there, you've got that overview, you can go to troubleshoot and so on. But when you're commissioning, you're starting from scratch. But why would it, like, you've got a £30,000 outlay for new technology to go and fault find a new equipment? How can you justify that with your managers? How does that work?
Quite easily. I guess, for us, for the biologics, the price of the product that you're actually making far outweighs the price of the asset, and it far outweighs the cost of the MA camera. So £30,000 might sound like a lot of money, but compared to a single batch in a biologics plant, it's not really much at all. So for us, the pressure on us is timelines, and the reason is, once we get approvals for certain therapies, we have to get that drug made and we have to get it to market as quick as we can. Time is literally money. So although the quality of the installation might be very high, there is also pressure on deadlines. So for us, a verification that an installation is good is worth its weight in gold, because if something does go wrong a little bit further down the line and you have downtime, that downtime costs a huge amount of money. So it's the cost of the camera itself is actually small compared to what the implications could be if you had a failure.
Yeah, so right in that commissioning phase, you're looking for those issues, and then so you're nailing them before they become later on.
That's right. That's exactly it. Yeah.
That's really good. So we've actually got one of your case studies as well. There's a bit more slides on it as well. So do you want to just talk us through these slides, what you've experienced there?
Yeah, sure. So this was in previous role. So this was a cooling tower pump. So normally for us, when you're on the utility side, there's lots of redundancy. So it's not as critical as when you're on the process side. But for us, this one came to effect because, like you can see, the top one there, the footing on the on this pipe support had basically disintegrated. It's fallen to bits. Yeah. So what happened was, for this is a good example of being on site with the camera and having the training to actually do something about it. I would have got the email, I think, about 9 a.m. and by 9:30 a.m. I would have been over there with the camera, and by about 12 I would have had the videos made, and this little thing emailed back to the people themselves to show where the actual issue was. And then by 3 o'clock I would have had that little drawing done of where I thought the best support would be for that, and then you're done and dusted within a day. Because to me, this would be a small issue. It's not a huge project, and you can't devote that much time to it. But if you have the tools and you know how to use them, you can knock these things out, and then you can come back to the rest of your job, because there's always lots of things to do. So for this one, it was kind of an example of how you're not just using this for rotating machinery, you're also using it for pipe work and also for structural supports. And it's an example of how easy it is to use. Once you give these videos to people, there's no debating it as to where your issue is. You can see it. It doesn't lie. So that's the beauty of it for me. So that pump, that issue, that pump there was actually two issues in one. So I think the first issue was the structural support issue. Yeah. And then they went away and they fixed that. And then, about 5 weeks later, they came back and they said, look, that pump is vibrating something terrible. I'm not sure if that pipe support thing worked. So the second video you showed there was actually You know, we looked at it with the handheld data collector. There was a huge rise in the 1x, which to me normally means you've either got a balance issue or you might have some kind of flexibility issue. But you know, if you got a balance issue in a pump and you want to check the impeller, it's a huge big deal to bring down the pump and, you know, to drain down and open up the pipework and everything like that. So the MRA camera again was used pretty quickly within about 2 hours just to look at all the pipework, look at the plinth, look at the base plate, just to make sure there's nothing loose, there's no cracks or anything like that, and there's nothing else contributing to what that actual rise in vibration could be before we got the guys to open up the pump work. And so that again is worth its weight in gold, because to do that, you've got all your permits, you've got multiple people involved, and at the end of it, the plinth and everything was actually fine. So when they opened up the pump work, they actually found that the strainer had disintegrated and was lodged in the pump itself. So it was a good find for me.
Brilliant. That's really good. Thank you very much for that, Paul. It's really informative.
Okay, no problem. Thank you, Keith.
We're going to invite Jeff and Stu now, and we're going to do this question and answer panel. So your questions that you posed in the chat area, we're going to pick some of those out, and the ones that you posted when you signed up to when you registered, we're going to use some of those. So if you've got any new ones now, just chuck them in that chat area, and Stu will be able to see them, and he'll prompt them for us to answer. And you can ask anyone on the panel, any one of us 5. So I'll just start sharing a little PowerPoint for us. Okay, so should be coming. Stop sharing. That's not worked for me. Application window helps if you do it right, doesn't it? Okay, there we go. Right, so our first question that I was going to put to the guys is somewhere here. So I've got one for Jeff. So a lot of people have been asking, and we've had it here in the chat and previously, is we don't use smartphone videos or DSLRs, and people are just kind of trying to get their head around that. Can you explain to us why we don't use smartphones for MA or DSLRs, which we know, like you said, I've got a DSLR, it's like 12 million pixels. What's the reason we don't use them?
Yeah, that's a really good question. So, you know, a couple of things I think to point out with that. You know, one, those are really optimized for creating nice pictures and nice videos. You know, really, you know, kind of, you know, photos and that's home movies, that sort of level of emphasis. So really, that's where they're designed. And so and the second thing is that they're really designed to make very small files, right? Because, you know, if you take a long recording on your iPhone, you know, you're going to fill up the space if you're not careful. And so they compress a lot of the data. And so a lot of that information that we're interested in is actually been eliminated in that compression process. And so that really makes the quality of the data pretty low for what we're trying to do. They're great for videos. They're great for photos. You know, if you're going to want to shoot you know, I think some people are even shooting, you know, sort of amateur level movies with the iPhone these days. But really for what we're doing in sort of data analysis, the detail is really lost. Right. The second thing really is that they're color. And so that's also great. But, you know, the color camera does something interesting with the spatial qualities. It sort of takes, you know, one pixel's really blue and one's red and one's green, and it smears all those together to make a color photo. So what a lot of people don't know is a color image actually has lower resolution than a black and white image. And so that's where we really go for the black and white, because it has all the information we need. And once you get used to just kind of looking at a black and white video, it's actually higher quality.
Oh, that's good. Well, thanks for that. So I've got the second question we've got there for, I think we'll go for one here we've had in, is how does, maybe to Stuart this, how does steam, dust and smoke affect the camera, Stu? What have you experienced? Just make sure you're unmuted there, Stu. Okay, same question to Phil and Paul. What would one of you like to comment on that? Yeah.
So for me, obviously, we use steam to heat our lines into our pumps and things like that. So, and we've always got steam leaks on our site. I don't know how we manage it, but we seem to manage it really, really well. Probably the same at other sites. So it doesn't actually affect the measurement as long as you can actually physically see the target of what you're looking at. What it does do, if it comes across in front of the lens, you do get a bit of the Hollywood effect. So you get some nice sort of smoky atmosphere around the thing, but it doesn't actually affect the measurement per se. So it's about making sure you've got your camera set in the right position. If you can minimize the amount of dust and the amount of chatter on the screen, then you're going to get a better result. So it doesn't really affect the measurement as long as you've got a clear line of sight to the target.
Yeah, I'd agree, and I've experienced the same. It's a case of getting the right setup and what have you. And you've touched there on background vibration as well. There's a little question there, and I found that as long as you there's some pads that come with the kit. As long as you place your camera in the right position and use your lenses, even if there is vibration on the floor, it will you can get away from it, and you can find areas that are node points, and you can eliminate it as an issue basically just by you moving around and being mobile with the camera. So Stu, you feel free to chip in with any questions you've got there from the chat, because I can't see that at the moment. Another question we've had for Jeff is a good one. What would you say kind of minimum levels for measurement, vibration levels for measurement, and also for amplifying? I feel that's a bit of a two-sided question. There's a minimum level for what you want to see with amplification, but what's also technically what we can measure, what's our minimums?
Yeah, so the way that the camera is kind of spec'd, or what we usually say is that 0.01 mils. So in SI units, metric, it's about 250 nanometers, and that's about a meter away. So if you move about 2 meters away, then that number goes up to 500 nanometers, or 0.25 or 0.5 microns. So you can kind of back out of that and kind of figure out what levels. But it's for machinery vibration, on the severity charts and sort of where you're looking, it's really, you're able to see things move out of the sort of the good category where it's moving well and behaving at levels that are appropriate into the fair to poor category. So it really allows you to see pretty much any level of vibration that you're going to be interested in seeing. And then the other thing that I would also just kind of point to on this is the fact that it's measuring displacement, which makes it very, very handy as a complementary tool to, say, acceleration, which is really sensitive to high frequency. And this is really great for the mechanical motions, where most of the outside of bearing defects, most of the motion resides. Okay.
Well, while you're on that as well, Jeff, is what kind of frequency range can we expect from this technology? What can we expect? What can we expect to get?
Yeah, so it really is dependent on the camera you're using. So what's interesting with cameras now, the sample rate, which kind of determines, how fast you can see, is the frame rate of the camera. So if you need to see something faster, you use a faster speed camera. And so the standard IRIS-M, it operates in the 100 to 200 hertz range. And then above that is where you get into the MX, which is a high speed camera. And that's the hundreds of hertz to, like 1,000 hertz or some, along those lines. Now, again, we're measuring displacement. So as frequency goes up, naturally the displacements go down. So, you're sort of getting diminishing returns after that with kind of imaging displacements. There's just not a lot of displacement, in the high frequency. So most things that you're interested in looking at are really going to be down into the couple hertz or couple hundred hertz range.
Okay, yeah, thanks for that. So I've got one here for maybe Phil and Paul, if one of you want to answer this one. Is do you need to be a vibration expert? Sorry, and what kind of training do you really need to have to be able to utilize this to the full? How would you answer that?
I would say you definitely don't need to be an expert. You know, if you compare it to, you know, taking a data collector out of its box and trying to figure all that out, I actually found it quite straightforward. A little bit of background in vibration is good. You know, if you understand your spectrums and your time waveforms, you definitely got a head start. But you know, the 2 days training that comes with the camera is very much enough to get you up and running and get on your feet. You know, and you know, we do kind of in-house vibration for the training for the MA camera, and what we do with our technicians is to encourage them to just take the equipment and go out and see what you can see. So you know, similar to infrared, you know, for infrared we say, you know, best way to use it is just grab it and go out and see something, and it's called infrared by walking around. And for this, it's the same. You know, we say to the guys, look, if you're on night shift and you got an hour or two, just grab the gear and go out and show me what you can find. And you know, generally they find something. You come in on Monday morning and you got a little video and they show you that this is what I found. You know, mightn't be a problem, but it shows you that they're using it. And I think it's quite straightforward.
Yeah. Oh, that's good. Thanks very much.
How do you feel, Phil?
Yeah, I totally agree with you there, Paul. I mean, you know, we've got guys who've had absolutely no formal vibration training whatsoever, and they've been out with me and used the equipment, and straight away they're straight onto the answer. You know, to the point where we haven't shown the video, but I went to another site where they'd had accelerometers all over a vessel for days, you know, trying to get to the bottom of a vibration problem. And we stuck it on, and the first thing the guy said was, "The base is loose." I mean, it was literally that quick. It was 5 minutes.
Yeah.
You know, he'd had no vibration training whatsoever.
That's spot on. Really good. So another one we've got in about run-ups. So does any one of us, the whole panel, anyone ever go at doing run-ups with the system? Like a run-up of a machine, I guess, or a coast down?
So
Stuart did one for us. Yeah.
Paul.
Sorry, Phil. Yeah, we had a fan when Stuart came over originally, and it was resonating up around 65 hertz, I think. Now we do have we did have a data collector with a faux, like a laser tack as well, so we could have done it that way. But like we say with the MA camera, far easier to do it just with the camera. So and Stuart demonstrated it, and we got some great results from it.
Yeah, oh, that's cool. Yeah, so I know I've done a few as well with Stuart. And Jeff, have you got any comments on there and what it's like for the kind of measurement that you get out of the run-ups? What sort of measurement do we get from it?
Yeah, you know, one thing that's interesting about it, and I'll kind of hit this idea of like the full field vibration, getting all this data. You know, it's really nice when you're going through, you know, sort of a run-up process. You know, you go through these different frequencies, and you're able to see the structure move. But what's nice about it is you're not limited to one location. So you don't get that, you know, sort of one data point. You can see the surroundings and how the entire structure behaves, and then measure anywhere in the scene. So if you're maybe doing the process and you're thinking you're looking for one area, sort of like what was discussed about the base, you really have a preconceived notion about where you should be measuring, and you do that, you might be missing something. And so that's one of the things the camera really affords, is the stability to see such a large area, because there's a lot you don't know that might be going on.
So you're filling in all the gaps, really, aren't you, with the camera, I guess?
Yes, yeah, quite literally.
Yeah. And if you
just another point that, Keith, sorry, is you know, where you, if you were to do a traditional run up, you know, where you try to put a laser tack on and get some tape onto a shaft, you know, but if you don't have any bare shaft to do it, then this might be your only way of actually doing something approximating to a run up. So in that sense, it's really useful.
Yeah, I think some like transient events as well.
Yeah,
you could only capture it through some of the transient events we've done. We've only been able to capture it if we use a camera. So yeah, it's good for that. So some other questions then. I had one about belt slip, and I know Jeff, you've got a really good example of belt slip. So maybe we'll get in touch with the guy in the chat afterwards about that. But yes, we can do. There's another feature in there we haven't even discussed of the system. It's not motion amplification as such, is it, Jeff? But explain.
Yeah. So, I mean, we want to maximize the camera capability, right? So motion amplification has has become one element of the tool, but you can track objects and measure, measure transient, get a spectrum of a moving object, things like that. So if you're interested in like robotic arms and measuring that, but the other is what we call shaft inspection. But really what it is it enables you to sort of lock on to specific frequencies and then inspect something that's turning. And it's really designed to be able to inspect it, but it's really nice to lock on to things that are like the pulleys and the belts, and to be able to actually see them move and image them and get the detail on them. So you can actually see sort of the different rates that things are moving, like if you're looking for slippage. And so it's a handy tool because you can, when you're in the field and you're already there, you can just put that extra sort of analysis on the asset.
That's cool. So just closing comments then, Jeff. Could you give us a little feel of like this? We've looked today at the ad hoc kind of MA side of it, the technology, how it works. What's in the pipeline? What can we expect to see a month from now, 6 months from now, a year, 10 years? What's your outlook for the future?
Yeah, so I'll focus on maybe the 1 year or so. I don't the 10 year, who knows, right? But
your brain, what you're cooking.
Yeah, it's really nice because the camera technology is evolving fast, and we can leverage that. New technology, technology comes out, new interfaces and things like that. We just released a pretty big update 3.0 that had vectors, and we have some interesting things coming out on the near horizon that I think are going to be interesting. I won't give away too much, but we generally do 2 to 3 updates a year on the technology that are pretty advanced updates. But
continuous monitoring had a big update, didn't it? So we can actually do triggering and online monitoring, can't we?
Yeah, and that's one of the things that I would focus on, kind of if you're talking about what's on the future. I think that there's going to be really some interesting developments with capabilities of being able to do that. So we just really advanced the continuous monitoring to where now you can use a TAC with it. You can trigger off of 4 to 20 inputs. You can leave the thing running for hours and collect, lots and lots of data over long periods of time, and be able to actually do sort of a different level of analysis on an asset that is not just maybe a simple troubleshooting when you're on the spot.
Yeah. Okay. Well, thanks. And we would have liked to have heard a bit more about what you've got the secret lined up for us in the future. Mm-hmm. We'll just have to wait and see. So I'll give a good thanks to everyone. For Jeff, thanks for joining us and getting up so early in the morning to join us on the webinar. And also, Phil and Paul, you've been champions. Really good to see you here today. We appreciate your input. And Stuart, I don't know if Stuart can hear me or not. I can't hear him. But thank you, Stuart, for your experience that you've shared with us as well. So I'm going to hand back to Joss now, and she'll just close up the webinar.
Thank you, Keith, and thank you to all our panel today. You've been absolutely brilliant. Thoroughly enjoyed this. You've been absolutely inundated with questions. So have we. And the big questions that we've got are, is this webinar going to be available on demand afterwards? And yes, the answer is yes. It will be on the Main Tech website, available to view on demand within a few days. But we will be emailing all of our participants today with an email link so that they can download it easily. Other than that, look out for further webinars coming from the Main Tech team over the course of the coming months. There will be further details on obviously the event, and details on the event are on the screen now. If anybody wants to contact me to have a chat about how they can get involved, please feel free to do so. But it just remains to say thank you so much all for your time, and we look forward to hopefully seeing you all again soon on another webinar. Thank you, RMS. Thank you, guys. Goodbye.
Thank you. Bye bye.
Thank you, everybody.